Welcome to this demo of Munin 1005 from Novator Solutions. Munin 1005 is an IF recording platform that ensures gapless recordings on narrowband and wideband signals ranging from 2 MHz to 600 MHz real-time bandwidth. This configurable platform is ideal for capturing one or more IF channels in real time, for device under test characterization and spectrum analysis. Munin uses a modular PXIe platform, ultrascale FPGAs, and RAID disk storage. Munin is built with a server-client architecture to separate the time-critical from the non-time-critical tasks. In this demo, I use a PXIe chassis with a controller, 2 digitizer cards, clock cards, and an interface cards to the external RAID. For the purpose of the demo, Munin Server as well as the client applications Munin Control and Munin RTSA Control are running on this chassis. For best performance, however, it is recommended to run the clients on remote computers. Munin Server is the main application of the Munin 1005 platform and controls the signal processing and file streaming. In the title bar, you can see the IP address of the server and the operational status. You see the system time and time zones, and you get information about the temperature in the PXI chassis. Under the File menu, you have links to configuration options and additional information about the system. Under the Operate menu, you control the status of Munin Server. Under the Help menu, you can find the user manual. In the Data tab, you see the status of the IF channels. IF1A and B are narrowband channels, and IF2 is a wideband channel. You can see that all 3 channels are active in the system, and the 2 narrowband channels are armed and ready to be recorded. You see the length and status of the pre-trigger buffers, and you see the format of the recorded files. The Logs tab shows 2 different logs. The TCP traffic log shows all commands that are received from the clients and all responses sent back from the server. The event log shows the system events, including errors and warnings. The logs shows only the latest entries, but the full logs are stored in the system and can be accessed from the File menu. In the bottom of the window, the latest event is displayed. Now I will talk about configuring Munin Server. Under the File menu, you find System Settings, which will open the System Configuration dialog. When Munin Server is installed, default system settings allow you to run the system with local clients. Under System General, you find settings like enabling logging and pointing out the license file. Under Network Connections, the settings for IP address and ports can be found, as well as heartbeat settings. Here I use a local host address. Under Network FFT, the settings for the FFT stream are configured. Under File Management General, you can choose to save the metadata for the recordings in separate text files, but I keep these settings off for the demo, so the metadata will be saved in the TDMS file together with the signal data. Under RTSA General, the real-time spectrum monitoring option can be enabled, but for now I'll leave this option disabled. Under RTSA Streaming, the settings for the RTSA streams can be found. There are settings for 3 types of stream: persistence, spectrogram, and spectrum. When the system configuration dialog is closed, if changes are made, you will be reminded to restart Munin servers for the changes to be applied. Next, I go to the hardware settings. You find this under the File menu. Here the digitizer settings comes up first. You can activate or deactivate the IF channels. You can configure the length of the pre-trigger buffers. Either set the buffer length manually or you let the system calculate the max available length depending on the installed amount of RAM in the system. Note that longer buffers mean longer time to arm the channels. Under File I/O, you configure where to save the recorded channels. It's also possible to configure the naming of the files. Under Timing and Synchronization, you configure the source of the system time. You can choose to use GPS via the clock interface module, or you can choose NTP, where you need to configure an IP address of an external NTP clock. I choose GPS. System time interface, IF2 channel clock source, and PXI backplane name should normally not be changed. Under Available Hardware, you see the installed cards in the chassis. If you have made changes, you might be prompted to restart Munin Server. Now I will demonstrate the license management in Munin 1005. Munin Server starts in evaluation mode if no license key is available. In evaluation mode, 1 second of data will be acquired at a time, after which the data will be all zeros for 9 seconds. This will continue for 512 seconds, after which the data will be all zeros. To enable full functionality, the system needs to be unlocked with license keys. Getting a license key is done by sending a license request file to Novator Solutions. Under the File menu, you find License Management, which will open the License Manager. With this tool, you can generate license requests and verify a license file. First, you choose the options you want to license. You need licenses for digitizer cards as well as for the runtime spectrum monitoring option. Then on the Generate License Request File tab, you choose a folder to save the generated requests. If you have bought Munin 1005 through NI-Tools network and received an activation code, you also add this here. Then you press Generate Request File. When you get this dialog, choose Append, then you will get all license requests in the same file. When the request is generated, send the request file to us at Novator Solutions. When you have received a license file, you can verify that it unlocks your system in the Verify License file. Browse to your license file and press Verify License file. When the verification is done, you see the status on the license status. Now all needed setup is done and I can go online with Munin Server. Munin Control is the client application you use to configure and control the recordings in Munin 1005. With Munin Server online, I start Munin Control. Munin Control has 4 tabs. On the Recording tab, you can start and stop recordings. On the Metadata tab, you add additional metadata to recordings. On the Playback tab, you can play recorded files. On the Advanced tab, you see logs for events and commands. In the menu, you have access to the manual under Help. and under File you can find the settings as well as links to the logs. System Settings open the System Configuration dialog. Under System General you configure the logs. Under Network Connections you configure the connection to Munin Server. Under Network FFT you configure the FFT stream. Since Munin Control is already connected with Munin Server, I don't need to make any changes. For this demo I have connected an antenna to channel 1A and a signal generated to channel 2. Center frequency for channel 1A and 1B is 160 MHz, and for channel 2 it's 1 GHz. Right now the bandwidth for channel 1A and 1B is configured to 80 MHz. For channel 2 the bandwidth is always 500 MHz. To record a channel you press REC. To stop the recording you press stop. After you stop the recording you can choose between continuing with adding metadata to the recording or cancel, which deletes the recording. Going to metadata, there are two fields where you can add text: the collector and the comment field. Pressing send will send this data to Munin Server. Munin Server will respond with confirmation of all metadata that will be saved with the channel. Besides the two fields that are editable by the operator, there are some system-generated metadata. Pressing save will save the recorded channel with the metadata and allow you to start another recording on this channel. For channel 1A and 1B, it's possible to record both channels at the same time. They are started and stopped individually. To record on channel 2, you first need to unarm channel 1A and 1B. This is done by opening the lock. Then you choose channel 2 and closing the lock to arm channel 2. Since channel 2 is a wideband channel, the large buffer takes some time to prepare. When arming is done, the recording can be started for channel 2. To look at the recorded channels, you go to the Playback tab. Here you have a list of the recently recorded files. When you choose a file in the drop-down list, the metadata for this file will be displayed. Then you press play to play the recorded file. Going back to the recording tab, I will also show how to change the bandwidth of the two narrowband channels. When the channels are unarmed, you can change the filter settings of channels 1A and 1B. There are 6 defined filter bandwidths, from 2.5 MHz to 80 MHz. The two channels can have different bandwidths. When the bandwidths are changed, you can arm the channels again. To use the real-time spectrum monitoring option in Munin 1005, you need to enable this in the system settings for Munin Server. You find this under RTSA General. With RTSA enabled and Munin Server online, I start Munin RTSA Control. The real-time spectrum monitoring option uses the FPGA or channel 2, so enabling this means that channel 2 will be disabled. For this demo, I have an antenna connected to channel 1A and a signal generated to channel 1B. In Munin RTSA Control there are three different graphs. Persistence, where previous spectra are retained for a while. Spectrogram, which shows a waterfall plot of the channel. And spectrum, which shows the real-time spectrum. The center frequency is 160 MHz. You can switch channel inputs between channel 1A and 1B. In the menu you have access to help, and under file you can find the settings as well as links to the logs. System settings open the system configuration dialog. Under System General you have settings for the logs. Under Network Connections you configure the connection to Munin Server. Since Munin RTSA Control is already connected to Munin Server, I don't need to make any changes. In the RTSA configuration dialog you configure the three graphs. For persistence you configure the refresh rate, which controls how many data packets will be sent from the server. Persistence graph max controls the maximum power value in the display. Persistence controls the relative time the spectra are retained in the display. Saturation controls the image saturation. And emphasis controls how short time events are highlighted. For spectrogram you can also configure refresh rate. Time span controls the span on the vertical axis. Mode allows you to switch between average or peak power for each point. And range controls the power range from which signals will be presented. For spectrum you can configure the refresh rate. You can also enable a grid in the graphs, both for time and frequency. Using Munin RTSA Control together with Munin Control, I will demonstrate how the pre-trigger buffers in Munin 1005 works. The problem with just using Munin Control when recording is that it's easy to miss short signals. The pre-trigger buffers are used so that when I start a recording, the information in the buffers will be added together with the data that is recorded after I press rec. I have configured the time span for the spectrogram to be the same length as the pre-trigger buffers, 10 seconds. So using the spectrogram, I can look for interesting signals. When I see signals of interest, I can start the recording or know that the information in the spectrogram will also be part of the recording. When I have stopped the recording, I can go to metadata. Here you can see in the system generated metadata that the trigger time and the acquisition time differs. The acquired data started 10 seconds before I started recording. This is the information in the pre-trigger buffers. When I go to playback in Munin Control and play back the recorded files, You can see the signals that we saw in the spectrogram are in the recording even though I started recording after the signals ended.